In this video, we're going to look at how we write functional groups in condensed formulas. How do we take care of the alkenes and the alkynes and the side groups, and just a few examples of how we represent those, particularly with the alkenes and alkynes, because that tends to be where students get tripped up. So what we want to look at here is how we get to the condensed structure for these alkenes and alkynes. There's really no difference in how we've done it with our alkanes. What we simply look at is we say, okay, I've got a carbon here that has 2 hydrogens attached, and I have another carbon with 2 hydrogens attached. So when we write that in the condensed structure, we write CH2, CH2. Now, keep this in mind when we go back from the condensed structure to the skeletal structure or the Lewis structure. We're only going to be able to draw in 2 carbons and 2 hydrogens, and once we do that, we can see that we'd have to have a double bond between the 2 carbons to complete the 4 bonds to carbon. We see something similar with the alkynes, only in this case we only have 1 hydrogen attached to each carbon, and we'll look at that with some examples, how we show that and how we get from the condensed structure back to the skeletal structure. Our aromatics, we really don't write the cyclic rings, whether they're aromatic or just single bonds, as anything different in the condensed structure. We can't really represent that. So we usually just draw out the structure either by showing the atoms or showing just this part of the skeletal structure. To find our condensed structure, we need to know how many hydrogen atoms we have involved here. And so the first thing I'm going to do is I'm going to look at my skeletal structure and I'm going to go through and draw in my hydrogen atoms. Now I'm not going to draw in all the hydrogens, but I'm going to show a little red line to represent each of my hydrogen atoms. So it makes it a lot easier when I'm writing the actual condensed formula. So when I look at the first carbon here, what I see is that this carbon only has 1 bond, which lets me know it's going to have 3 bonds to hydrogen. My second carbon already has 2 bonds, so it only needs 2 bonds to hydrogen. My third carbon, now we have something a little bit different here. This third carbon already has 3 bonds because it has 1 bond to a carbon here. It has 2 bonds in this double bond there, so I only need 1 additional hydrogen on that atom. Same thing goes for this carbon, that it has 4 bonds total now when I add the 1 hydrogen. Now I look at 2 hydrogens for that carbon. I get to the carbon here with the methyl side group, and it has 3 bonds, so it's only going to need 1 hydrogen. Same thing here for this carbon. And I get to the end of the molecule, and I see that this carbon at the end only has 1 bond, so it's going to need 3 hydrogen atoms attached to it. Now I see that one more up here, I need CH3 as well. Now I see that all my atoms have 4 bonds. Some of them are from carbon bonds, some of them are for bonds to hydrogen, and one's even a bond to chlorine, but they all have 4 bonds. Now I can go through and actually write out the condensed structure. And what I'm going to do is basically read the molecule from left to right. I'm going to start here with my first carbon, and when I do that, I can write CH3 because that's what I have there. I look at my next carbon and I have CH2. I look at the third carbon. Now I'm not going to show the double bond in my condensed structure. What I'm going to show is that I have a carbon with just 1 hydrogen attached. And the next one is the same thing, a carbon with 1 hydrogen attached. Now I'm on this atom and I have CH2. Then I go on up to the carbon here. I have CH, but I also have a methyl side group, and I have to put that in parentheses so that we know that that carbon is not part of the chain, that it's off to the side. Then I look at with my carbon here that has a chlorine attached, so I can say CHCl, and I don't need to put the Cl in parentheses because chlorine must be a terminal atom, so it must be off to the side. It's not like a carbon atom that could be in the chain, but the chlorine has to be off to the side. And then I look at my last carbon here as CH3. So now I have the condensed structure. And I don't really show that double bond in my structure, but what I'm actually going to do is I'm going to look at just this little segment right here of my structure. And so if I'm going through my molecule and drawing this back into the skeletal structure or Lewis structure, what I can see is I've got a carbon, and I know there's a bond to carbon, so I guess I'm actually looking at this chunk here. So it has 1 bond to carbon. I have another bond to carbon, and another bond. I know this continues on. Okay, I'm not worried about kind of this rest of the molecule here. What I'm worried about are these two carbon atoms here, because those are the ones that each have a single hydrogen attached. So when I look at this, the condensed structure shows me all the hydrogens I have. Now, skeletal structure doesn't show any, so I can draw them in, but I'm either going to go all or nothing. Either I'm showing my hydrogens, or I'm not showing hydrogens. So when I go from a condensed structure and I only see that I have one hydrogen on each of those carbons, I know that that's all the hydrogens I have. So what I do is I look at this carbon atom, and I say, okay, this carbon only has 3 bonds. I can't put more hydrogens on because they weren't in my condensed structure. However, what I can do is create a double bond here. And when I do that, now both of these carbon atoms have a double bond. So by looking at the number of hydrogens in the condensed structure, we can get back to what the skeletal or what the Lewis structure is. And we'll look through some more examples of this, but this is just the first one we're looking at here. So now I want you to pause the video and take a minute to work out this problem. Remember what we did on the previous example. We drew in our hydrogen atoms and then we read the molecule from left to right. Hopefully you tried to do this on your own first. I'm going to go through it here just so you can check your work and figure out anything you did incorrectly. I'm going to go through and draw my hydrogens. So I need 3 there. I see this carbon here already has 4 bonds. I'm not going to add any hydrogens there. The carbon up here has 3 hydrogens. I need 1 hydrogen there to make 4 bonds. 2 there, 1 there, 3 and 3. So now I've added in all the hydrogens. Now all my carbon atoms have 4 bonds to them. Now I can start reading across my molecule and showing my condensed structure. So I start with CH3. Then I have a carbon. Note that this carbon doesn't have any hydrogen groups attached, so I'm not going to show them in my condensed structure. But I do have a substituent group that's a CH3, and I put that in parentheses to remind me that it's off to the side of the main chain of the molecule. Then I go to the third carbon here, and I have CH. Then I have a CH2, CH with a CH3 group attached, and then another CH3. So now I've shown the condensed structure for the molecule shown as a skeletal structure by adding in the hydrogens and then kind of translating that into my condensed structure. Another one for you to try. Draw in your hydrogens, draw out the condensed structure. We have an alkyne this time with our triple bond there. And we also have an OH group there, which hopefully you remember is an alcohol group. So this molecule actually has 2 functional groups. Now, we're not going to name anything like this where we have to deal with competing functional groups. So don't worry about nomenclature for this. What we're worried about is translating this into a structural formula. So pause the video here and take a minute or so, whatever you need, to solve this problem. So I'm not going to approach this problem really any differently than I have the others. I'm going to add in my hydrogen, so I've got 3 there that I need. My second carbon here doesn't need any more bonds, it's got 4. The third carbon doesn't need any bonds. The next carbon needs 2, then I need 1 there and 3 there. I've got an O up here, it only has 2 bonds, it's already showing everything that I don't have to draw any hydrogens there. So now what I can do is again go through and draw my skeletal structure. And so I start with CH3. Now I have a carbon and a carbon because I don't have any hydrogens attached to either of those carbon atoms. Then a CH2, CH, OH, and then a CH3. Now with OH groups, we sometimes see them in parentheses, sometimes out of parentheses. Just to make sure we're not talking about an ether, it's always a good idea to put OH groups in parentheses so it doesn't look like the O is actually part of that chain, because an oxygen can be part of a carbon-oxygen-carbon chain, or it can be attached to the side of the molecule. So to avoid any confusion over that, it's okay to go ahead and put that OH group in parentheses. Now let's look at an example of how we do the reverse process. How do we get from a condensed structure to a skeletal formula? Well, I actually take this in two steps. I'm not going to go directly to my skeletal structure. What I'm going to go to is actually drawing out the Lewis structure and then draw my skeletal structure for that. So the first thing I actually want to do is figure out how many carbon atoms I have in kind of my base chain in my molecule. And so I go through, I see I have 1, 2, 3, 4. This carbon is in parentheses, so I know it's part of the side group. It's not part of the main chain of the molecule. So I got my 4, 5, and 6 carbons. Now what I can do is actually go in and draw my 6 carbon chain here. 4, 5, and 6. And now I'm going to go back through and put in all my hydrogen atoms that I know I have. So I start here with the one here on the left. It's got 3 hydrogens attached. I look at the next carbon. It has 1 hydrogen attached. My third carbon has 1 hydrogen attached. My fourth carbon has 1 hydrogen, but it also has a methyl group. It has that CH3 group attached there. My next carbon doesn't have any hydrogens attached, and my last carbon just has 1 hydrogen attached. So now what I need to do is figure out which of my carbons do not have 4 bonds. So I start here with my first one. I have 4 bonds. I look at the next carbon atom, and I see that it only has 3 bonds, and that lets me know that I'm going to have to make a double bond there. I can't add more hydrogens in this case because I did not have those hydrogens in my condensed structure. I can't add more hydrogens once I've already put in the one that I was given in the formula. So I know if I put a double bond in, that's going to make my carbon atom here, oops, wrong button there, makes my carbon atom here have 4 bonds. It also satisfies the 4 bonds for this carbon atom. Now I see this one has 4 bonds around it. I get here and I see I only have 2 bonds. Now I can't interfere with this bond because this carbon is happy. It doesn't want any more bonds. So that means any change that has to happen on the other side, has to happen on this part of the bond. And I see that carbon only has 2 bonds. It needs 2 more. And in order to get that, it's going to have to form a triple bond. And so now I see that I've got a carbon triple bonded to a carbon, which works out great because now I have 4 bonds around this carbon and 4 bonds around that carbon. So now that I have the Lewis structure, now it's a lot easier to go back and actually draw the skeletal structure. And I'm going to start again by first drawing my backbone. I know I have 6 atoms in my chain. So 1, 2, 3, 4, 5, 6. I know that between carbon 2 and carbon 3, I have a double bond. So I'm going to draw in my double bond there between carbon 2 and 3. I get to carbon 4, and I see that I have a methyl group attached. So I'm going to go down, still counting the same direction. I can't change around how I'm counting. So 1, 2, 3, 4 is where my methyl group is going to be. Then I see that between carbon 5 and 6, I have a triple bond. And so I can go ahead and draw that in on my skeletal structure. So now I show the exact same thing in all 3 of these structures. I'm just showing it in a different way. Here I have my condensed formula. Here I have the Lewis structure, and here I have my skeletal structure. And on the skeletal structure, remember, I don't have to draw in the hydrogens because I can always figure out what they are. All right, here's one for you to try. Pause the video now, work on this problem, draw out your Lewis structure, and then convert it into a skeletal structure. I'm going to take the same approach as I did before. I'm going to go through and figure out how many carbons I have in my main chain in my molecule. So I have 1, 2, 3, 4, 5, 6, 7, 8 chains in the 8 carbons in my main chain. And so that's the first thing I'm actually going to draw out is those 8 carbons. Okay, so I have my 8 carbons there. Now I can go through and start putting in my hydrogen atoms. So I see here I've got 2 hydrogens on the first carbon. I go to the next one, I have 1 hydrogen. Then I have 2 hydrogens. The next carbon I have hydrogen, hydrogen, 2 hydrogens. I have a hydrogen and a bromine. Remember, the bromine doesn't need to be in parentheses because we know it has to be a terminal atom. And then I have 3 hydrogens on this terminal carbon atom. So now I've got to go back there and see where I need to put in multiple bonds to make sure that every atom or every carbon atom has 4 bonds. So I start here at the beginning, and what I see is that I have 3 bonds, so I know I need to add a double bond in there. So now my first carbon has 4 bonds, the second carbon has 4 bonds, my third carbon has 4 bonds. I look at these 2 carbons, I see that this carbon is missing a bond. It needs another one, so I'm going to have to make that a double bond. So now I have 4 bonds here, 4 bonds here, 4 bonds, 4 bonds, and 4 bonds. So now that all of my carbon atoms have 4 bonds, now I can go and simplify this a little bit and draw it as my skeletal structure. So I'm going to do my 8 carbon chain backbone first. So 1, 2, 3, 4, 5, 6, 7, and 8. Remember, we have carbon atoms at the ends and at the intersections of each of these line segments. So we have 8 carbon atoms. I look back at my Lewis structure and I see between the first and second carbon, I have a double bond. And so between 1, 2, 3, 4, and 5, so 1, 2, 3, 4, and 5, I have a double bond. And then 6, and then on carbon 7, I have a bromine atom attached there. And that takes care of all my double bonds. I'm not showing the hydrogen atoms in the mix, but now I have the skeletal structure of my molecule. Now, we talked about the numbering. We kept saying, well, this is number 1 here. We've got a double bond and we've got a bromine group there. We're not going to deal with naming where we have mixed functional groups. So don't worry about the nomenclature with respect to that. When you're trying to draw the skeletal structure, it really doesn't matter which end you're counting from as long as you're consistent so that you can make sure you get the double bonds and any side groups in the correct place. Hopefully this has helped you figure out condensed structures a little bit. If you have any questions, as always, please feel free to come see me during office hours, post on Piazza, or email me to make an appointment to meet at another time.